mode.
Hi, everyone, and thank you for joining South Shore Clean Cities, Wisconsin Clean Cities, and Chicago Area Clean Cities coalitions for our CNG, LNG, LPG, and repair and maintenance facilities code issues and compliance webinar. This is the second webinar of our series for our 2014 webinars. These are funded by the Lake Michigan Corridor Alternative Fuel Implementation Initiative. All webinars are being recorded and will be made available after the session on the Chicago, South Shore, and Wisconsin Clean Cities websites. The Lake Michigan Corridor is an alternative fuel implementation initiative supported by the Department of Energy through the Clean Cities Implementation Initiatives to Advance Alternative Fuel Markets program. Under these projects, local public-private partnerships are have accelerated the deployment of alternative fuel vehicle and conducted public outreach and training in communities across the country. Since 1993, the Energy Department's Clean Cities initiatives have supported community-led efforts to deploy vehicle and infrastructure technologies across a broad portfolio of alternative fuels, helping to reduce America's reliance on foreign petroleum. And first today we have leading off Ted Barnes with GTI, Gas Technology Institute in Illinois. So take it away, Ted. Thank you.
Good morning, everyone. My name is Ted Barnes with the Gas Technology Institute. For a brief commercial, we're a nonprofit research lab that's been around for about 70 years doing natural gas and other energy research. And my job today is to set the stage for two other presenters. I will cover the codes and standards, the more boring side, but the letter of the law, and then the other two presenters will go into some more detail of projects that they've done, some more specifics, some more pictures, some lessons learned, things like that. I'll start out by doing a natural gas overview and then go into propane towards the end, and I'll try to do a little more detail on propane since the other presenters have covered more natural gas facilities. The first thing to always talk about in maintenance facilities and in all things with natural gas vehicles is safety, of course. There's many hazards and there's many precautions that can be taken. I'm going to try to go through these slides relatively quickly to give everyone else a lot of time. But these will be available on all of the local Clean Cities websites, so you can go back and reference these. The main thing I want to point out on this slide is when I reference specific codes, these are the codes, the IFC, the International Building Code, IMC, International Mechanical Code, NFPA 30, NFPA 52, and 70, and the versions that it came from. So if you're looking at something different, it might be a different year or a different version of those codes. The first step in looking at a CNG or LNG facility upgrade for garage maintenance shops, first thing is to determine if you have a major maintenance or major repair shop or minor repair shop. I'll have another slide here that goes into a little more detail with that. The second is that the code compliance of the existing facility is a major key. If your existing maintenance shop is not up to the national codes, well then it's clearly not going to be up to the codes for any alternative fuels. And the other unknown is the involvement of the local code official, the authority having jurisdiction. They can establish their interpretation of the codes and guide the process for you, and that can help or hurt the process for sure. So the first thing to look at is the major versus minor repair activities. If you're performing only minor repair activities, and those are oil changes, tune-ups, brakes, tires, things that don't impact the fuel system essentially, then typically there's very minor or potentially no changes that you need to make to your facility if your facility meets the current national codes. When you do have to do some more modifications, It typically comes under when you're doing major repair activities, and that's things that involve the fuel system, major bodywork, painting, things like that. And an important distinction is where that major work is done is where modifications need to be made. So if you can separate out where major repair work is done and make facility modifications in that location, you can save yourself some time and money. But the other presenters will go into some instances of that as well. One of the major modifications that does have to be made sometimes is the ventilation requirements. I have a bunch of tables throughout this presentation. I'm not going to go into the letter of the code and how each one varies right now. If you do have specific questions, please send me an email or send notes. There's a lot of information on these slides, and so please use it as reference. And the way these slides are broken down are there's a baseline, and that's what traditional fuels, gasoline and diesel, need to be held to. And then there's a CNG and then an LNG section on these slides as well. And that breaks down how each of the fuels differ and how each of the codes that may apply. Sometimes the international codes are applied, sometimes it's only NFPA. So please look these over, and if you have specific questions on how it applies, let me know. A key to ventilation requirements are where that asterisk is in the middle. For the International Fire Code, it has an allowance so that you do not have to have continuous ventilation in a facility with natural gas, even a major repair area, as long as you have proper gas detection. And then the ventilation can be turned on as soon as the gas detectors sense that there's a harmful amount of gas in the area. The other key that the codes go over are electrical classifications. These are the baseline for electrical classifications. It's typically, for traditional fuels, the worry is for 18 inches from the ground up, because they're worried about liquid fuels. The difference for natural gas, since it's lighter than air, the concern is 18 inches from the ceiling. So often changes that need to be made to a facility are tied into the lighting or heating units that can be up in the ceiling or above maintenance bays. A note here is that hazardous area classification can be avoided by supplying continuous ventilation, and that's in NFPA 30A and NFPA 70, the National Electric Code. Gas detection, as I mentioned in a previous slide, it's not required by code, especially for CNG, which is typically odorized. But where it does come into play often is that if you have it tied into the ventilation system, you don't need to have a continuously running ventilation HVAC. And as you can imagine, and as this winter has proved, it could be a very high just operating cost if you had to continually run your HVAC, in cold weather, as this entire region has seen plenty of. And then there's some details on what that gas detection system needs to do and what the settings need to be. And this is a little more detail and where in the codes you can look to see what gas detection will affect and when it needs to trigger the ventilation system. The other major concern is heat-producing appliances, and that's often open flame heaters that are in many garages. If you're using natural gas, open flame heaters or anything with a surface temperature above 750 degrees F are prohibited, and that's in the major, or depending on the interpretation, that can be in major and minor areas, and that's just a key in order to keep flammable mixtures of lighter than air fuels from raising up and touching an open air heater. Another part that is not addressed as often when looking at facilities is vehicle prep. Uh, so when you talk about how to operate a shop, getting the right procedures in place is very important to the whole process. Typically, for all fuels, there's code requirements to close the valve from the fuel tank, and also to make sure that the vehicle is not leaking fuel before it comes in. That's seen in IFC as well as in A52. There are several requirements in NFPA 52. Chapter 6, Sections 13 and 14 have a lot of very good detail on procedures and defueling of a vehicle before it enters, when that is necessary, how to perform that. So when you look at the major steps to determine if or how extensive modifications are needed, the first thing is your facility audit. You'll look to see if you're code compliant to begin with for traditional fuels. You look to see if you have minor or major repair activities. The second step is look at your fuel types, that you're planning the fuel types of vehicles that you're going to do maintenance on. That will drive you to your codes, as well as your local authority having jurisdiction, your local code official, and then look at the shop modifications: ventilation, gas detection, hazard area classification, sources of ignition, and procedures. There are some more examples and really good resources that are online, that are free, that can help you go through this and see. You're always going to need to have an engineer on site or have someone design it, but this is a great way to kind of point you in the right direction. This first document from the Clean Vehicle Education Foundation is very extensive. It's about 35 pages, has a lot of details in it. The second document here, Steve Arnold from ET Environmental actually wrote this or was very involved in it, and so his presentation will go over a lot of this material, but it has a lot of great detail on this. And then also, I have a slide here that just used for reference, one for Illinois, one for Wisconsin, and one for Indiana. Depending on where you're located, you can come back to this slide, go to these links. What it does, it shows where, what the basis code will likely be for your region if you don't know. Of course, always go to your local code official. They will drive the whole process, but this can hopefully at least get you pointed in the right direction. Excuse me. The major takeaway, and this is, I just want to, this is a lot of dry material, but if you're going to come away with one thing for natural gas, or four things, I guess, are these major takeaways. Look to see if your major or minor repairs in your shop. A key thing that can help you reduce modification costs is the second bullet, that the separation of a major bay can minimize the modifications. That it can be separated by a wall, it depends on your specifics, but a 2-hour firewall or other requirements. Third bullet is gas detection is not required for CNG, but it can reduce your operating costs. And then the fourth is really a major part that cannot be overlooked, is that no matter what your facility is made to and how it was approved, having people and procedures in place are the only thing that will make a safe shop, and it'll only be the only thing that will lead you down the right path. So make sure that you have the proper procedures and technicians that are aware of the hazards of new fuels. So now I'll go into propane. I'll try to go a little slower here just because the other presenters are going to speak mostly to natural gas. But in general, it's a very similar path that I tried to take with these slides. A little on the physical characteristics of propane. It's classified as a flammable liquid, so unlike natural gas that is always in a lighter than air gaseous state, propane, when it's stored in a vehicle, is in a liquid state, and it will evaporate, but that gas is heavier than air. and so it will stay near the floor. Because of that, the codes are very similar to traditional fuels. And the hazards and the precautions are very similar to what you have to do for traditional fuels. Once again, here's a slide so that you can go back and reference where all of the codes come from, what versions. These don't necessarily apply to what your local municipality will be looking at, but these are the most current codes. So hopefully have the best understanding and the most current revisions. So if you have propane in your facility, it's similar. The facility audit stage is very similar. You want to determine if you have a major or minor repairs being done. Clearly, you have to involve your local authority. You have to determine what your key codes are and what they will be approving your facility on. The major difference with propane versus natural gas is that mostly if your facility meets traditional fuel, gasoline and diesel fuel maintenance codes and standards, it will mostly meet it for propane as well, because the fuel is similar and the hazards are similar. It's the same 18 inches from the floor up is where your real hazard areas are. There are some smaller differences, but it's much more similar in nature, and the codes are more similar in nature to gasoline and diesel. Ventilation requirements, typically there are really no changes for propane facilities as long as you have the base requirement. If you meet the baseline, it's typically the same. The electric and hazardous area classifications are very similar. Some of them, NFPA even mentions propane in some of the traditional fuel areas. Sources of ignition are a concern as well, but because the gas is heavier than air, it has different requirements. The concern is near the floor again, so there are no additional code changes for propane. Vehicle prep, there are some differences because the fuel in the vehicle is stored at a lower pressure, but still, in the hundreds of psi area. So there are concerns there. Code dictates that you should shut off the valve on the fuel tank. Leaks need to be checked and made sure that there are no leaks in the system. The NFPA 58 is the major U.S. federal code that covers propane. Chapter 10 has a lot of good details on that. As far as more on vehicle prep, Section 9.7.3.6 of NFPA 58 has a lot of the vehicle prep codes, good practices. The operator shall be in attendance at all times while the vehicle is indoors. Leaks in the system should be repaired. Tank valves should be closed. Propane should be removed from anything in the fuel system that is being worked on, such as this. And where this applies is very specific, and so please either ask specific questions or read the code in detail for your specific application. Then steps for garage modifications, it's very similar. You have to look to see if the existing facility is code compliant, if they're minor or major shop activities, and that just drives, just as it does with gasoline and diesel, it drives the type of modifications or the type of ventilation and such that you'll have to do. Then move on to meeting with your AHJ and affirming compliance, and then making modifications as necessary. For resources here, the PERC is a Propane Education Research Foundation, Council, sorry. They have a lot of good information on all types and questions for propane vehicles. This link here is a very good 5 or 6 page document that goes over a lot of the details for shop modifications specifically. So if you have additional questions, go to this. Once again, I've cited the Illinois, the Wisconsin, and the Indiana codes. You can come back to this depending on where you are, determine as a baseline what codes will apply to you. And then the key takeaways for propane is, number 1, evaluate if your facility is code compliant for traditional fuels. And then number 2, same as with any shop, having good people, trained, certified technicians, and good procedures in place is the key to having a safe, reliable workplace. And this is my final slide. We put this up because GTI is funded by the federal government, and this is their acknowledgement and disclaimer of everything that was said here. But as I mentioned, please email, or you can email Stephanie or Erica, or put in questions to the webinar here, and a lot of the details have to come out to specific questions, of course. But I will pass it along now.
All right, this is Steve Arnold. Am I on? Okay.
You're good, Steve.
All right, I'll just get started here. So I'm going to take what Ted had said about the natural gas vehicle garages and sort of expand that into, one, explain some of our efforts that we've done in the past, and then try to give some real-world examples, including some cost. So what I'm going to talk about, I'm going to focus a little bit mostly on the Wisconsin-specific requirements, although that doesn't mean I'll mention sort of the national level and other requirements, but because of the study that we've done in Wisconsin, they've got a lot of, or several nuances there. I'll jump into some case studies, show you what other facilities have done, touch on costs a little bit, and then Q&A, which I think we'll actually save till the end of the presentation. So just a little bit about ET Environmental and where we're coming from. We've modified over 50 facilities for CNG compliance and assessed at least double that. We've got offices across the country and have been doing these projects for the last 5 years or so. So a lot of this background is going to come from an effort we did with the Wisconsin State Energy Office. In fact, they had identified a need to provide fleet owners and building officials with more information on repair garages because it had been sort of vetted out that fleet owners didn't understand exactly what they were getting into for scope of work and cost, and so this effort was mainly focused on helping define some of those elements for both owners of garages and for the state building officials. We did work pretty closely with the State Energy Office, DSPS, which is the Department of Safety and Professional Services, and then also fire officials and fleet owners across the state. These are the same codes that Ted had listed. One sort of nuance with Wisconsin is that they've adopted codes on a state level with the exception of the International Fire Code, and most of that is controlled at the local level. They have adopted the IFC, the International Fire Code, on a state level, but that only applies to maintenance and operations and not to design aspects of these shops. So as Ted had mentioned, every shop is unique. Consult a professional and to get better costs and real scopes of work. And also I want to second what Ted had said about operations and training, and that's really the way that we're going to make our facilities safe along with the building modifications. So I'm going to breeze over some of this stuff, but again, this is all familiar from what Ted had said. The ventilation, gas detection, heating systems, and electrical systems are the major components related to shop upgrades. Wisconsin's adopted the existing building code, and this gets into the subject of fixing existing conditions that may be not compliant, or when you would be forced to upgrade to current code requirements, even if your facility was built a while ago and codes have changed. So that has all the rules related to that. We're going to talk mostly about major repair garages, and what I want to do is provide a little bit of real-world examples of how we implement some of these code requirements. So first off, on the ventilation, two distinct types of ventilation. One is normal occupancy ventilation, which is normally from the floor in a diesel and gasoline shop. This is where you want to remove your vapors from. But then we have the purge ventilation as well to evacuate a natural gas event. And one note on the occupancy ventilation, you may have seen the other slides mentioned 0.75 CFM per square foot. Wisconsin's dropped that down to 0.5 CFM per square foot, and that's applied across the state. So with this purge ventilation, I'm calling it, this is what we would do on a gas detection or continuously, depending on how you want to comply. But that airflow is from low to high. You want to exhaust from the ceiling, which is opposite your normal occupancy ventilation at 5 air changes an hour. And there's 3 ways to operate it. You can operate it continuously, interlock to gas detection, and for CNG vehicles, there's a 3rd way, and that's interlock to the lights or a while occupied type of ventilation. And the compliance strategies are usually roof-mounted fans like you see in this picture. One thing about the roof-mounted fans is we know that they're going to be turning on and exhausting air after a detection, for example. And for that reason, we want to make sure that these fans are rated for that environment, meaning they have non-sparking fans and their motors are electrically safe or at least not in the airstream of that hazardous air that may be exhausted. Now, how many and where do you put them? So we got the quantities and what it needs to do, but it's really a case-by-case basis. But what we want to basically prove is that we can effectively ventilate any place in the shop that could accumulate or would have compressed natural gas or natural gas present. That could be CNG or LNG that's evaporated. Next topic is detection. And we know a lot of times we use it in northern climates to control the ventilation, but what's not specifically talked about in the codes are how many of these things do you need and where do you put them? Well, you want them at the ceiling because that's where you want to detect your gas as close as you can to the ceiling. And then depending on who you ask, you get some very, very wide range of answers on how many detectors you need. We know that natural gas disperses fairly rapidly. And the short answer is you want a detector any that could detect a leak anywhere in your shop. If you were going to have vehicles in any positions that you could have a CNG vehicle, you ought to be able to detect a leak in a timely manner. One thing that's also not clear and sometimes enforced, sometimes not, is do we tie this detection event to a fire alarm system or to your monitoring company who will be monitoring the fire alarm? And really, that's a case-by-case basis. There's no hard code requirement that says you need to do that. In fact, in the case of a detection, you haven't detected a significant event like a fire event, as you would normally have with any other fire detection system. But you've detected a leak, and in fact, supposedly we have systems, and we design these buildings to have systems to clean up that leak automatically. So there's a pretty good case for that this is different than, say, a smoke detector or a flame detector. One thing about the detectors is that they actually need to be calibrated at least semi-annually, and it varies depending on the manufacturer. But you need to check them. Usually it's 2 times a year with some test gas and make sure that your calibration is correct and zeroed properly. One other aspect that comes in with the gas detection is detection is one thing, and then you need to tell the rest of the building systems what to do. What we usually end up with, sometimes it's integral to the gas detection system, and sometimes it's an add-on, is a relay panel. This relay panel can do as many things as you want it to, but what it has to do is sound alarms, turn off the heat, and turn on the ventilation system. And in addition, you can have it do things like open garage doors for fresh air intake. You could have it turn off your welding circuits, not a code requirement, but maybe a owner preference. You could also have it disable all non-essential electrical systems. We've seen that approach taken by some owners as well, and that's sort of on the conservative side, but possible. One thing with the gas detectors, you have generally the same requirements if you have LNG vehicles in your shop, although if you have LNG vehicles, you also need a gas detector in any service or lube pits as well, which of course are the most expensive ones to put in because you have to trench across your concrete floor. The heat, I talked about the basic requirements of the heat, 750 degrees and no open flames. What you see in the picture here is a non-compliant heater. In fact, it's a radiant heater that's a sort of a high-intensity model. It exceeds the 750-degree limits. We can tell just by the red color there. And then most heaters that you'll find in shops, unfortunately, are non-compliant. What else could be non-compliant that we often run into are used oil burners and pressure washers that would be heated by maybe a natural gas pressure washer. So you have to be careful about those too. And the rules are a little bit tricky in that they say that you can't have these systems any place that there are ignitable concentrations of gas. And it's been sort of industry practice to assume that your entire shop is subject to ignitable concentrations of gas unless you can make a good argument otherwise. And we have made that argument in some cases. So what is compliant heat? One, I was recently in a shop that had floor radiant heat, which was very nice, so there were no heaters to replace. Low intensity radiant heating, it's not uncommon. Many manufacturers or several manufacturers make a radiant tube heater that satisfies the requirements for natural gas vehicles. You could also use an air handling unit that would be located and such that it wouldn't have burners that are subject to the shop air environment. You couldn't recirculate air back through that unit. Also steam heat, which I've seen one shop that had that scenario. So here's a picture of a shop that we did, and it has the infrared, the radiant heaters, low intensity radiant heaters here that are compliant. Electrical is the next one. Normally, everywhere that I'm aware of, except for Wisconsin, has this classified area at the ceiling. Except for in Wisconsin, passed in December of last year, they made a code revision that says if you have the ventilation, as we just talked about, that's compliant for NGV garages, then you've eliminated your classified area at the ceiling, which is a huge cost savings. And my hat's off to Wisconsin for making that revision. The next subject is adjacent occupancies, and what we need to do is basically keep the hazardous environment or natural gas up near the ceiling from migrating to adjacent spaces such as offices or wash bays if those are not going to be set up to be compliant. There are several ways to accomplish that, either with positive pressure in the adjacent occupancies or just sealed separation walls. Now, there's been differing opinions on what that separation needs to be fire rated or not, and the approach that we've been taking and others have as well is that if there's indoor fueling involved, you definitely have to have a fire separation wall, or there are other code requirements that are driving a fire separation wall, you need it. But if you're simply trying to keep a hazardous environment from natural gas vehicles from migrating to a different space, it's not a firewall. In fact, it's just mitigating measures to prevent that migration of gas. So a few other sort of odds and ends. If you have LNG in the shop, you need to be careful of that LNG entering a closed drain system. If you have floor drains in your shop or oil water separators or sump tanks, because LNG expands 600 times when it vaporizes and can act more like an explosion during a vaporization, a rapid vaporization if it were to come in contact with water. So it's just something to be aware of. If you have open drains, there's a pretty good argument for doing nothing, but it needs to be addressed on a case-by-case basis. The other thing for shops, LNG vehicles in shops, is that they will spontaneously vent when pressure builds in their tank just due to normal heat gain. Code requirement is at least 3 days minimum hold time on those tanks. However, once you exceed that pressure in the tank just from normal warming, it's going to spontaneously vent inside your shop. And so there are some code requirements. NFPA 52 addresses it, and Chapter 15 that you need to be able to mitigate that hazard. What it doesn't say is how you do it. So there are differing opinions there, but we think there's a solution within reason. So I'll briefly touch on existing building code. This is adopted in I think it's about 39 states. Wisconsin's one of them. It identifies triggers that if you had a non-compliant shop to begin with, what you need to upgrade. It's driven by the level of change that you're doing in the building. They're classified as level 1, 2, and 3. Level 2 is common for the types of upgrades that we're typically seeing in a major repair garage. And a change of occupancy, interestingly enough, is applicable in this case because it involves a change in the application of the code. So what we know is that anything new that you put in must comply with current codes. Wisconsin said that energy conservation, this is a big one for Wisconsin, that if you're adding any heat load, for example, to the building, that you don't need to go through and do an energy audit and upgrade all your insulation in the building as well. Another one that commonly comes up with rooftop fans is the 5% rule. If you're not loading existing structures more than 5% of what they're designed for or currently loaded, then you don't need to do anything. If you're loading them more than that, which is not uncommon when you're putting a roof fan on, you need to address structural considerations as well. And there are triggers for automatic sprinkler systems in buildings that don't already have them. It's not common that they get triggered, but this is something that you should take up with your fire official. We don't need to hit this too hard, but this is the in simple form, the natural gas vehicle garage repair requirements. Minor garage, Ted talked on that, so I don't want to repeat too much of this here. Wisconsin, one thing about Wisconsin, so electrically unclassified area at the ceiling, they're exempt from heating requirements in Wisconsin. Here's the one kicker in Wisconsin is the ventilation, in that the International Mechanical Code is adopted by the state, and there's actually no exception for a minor repair garage to deal with this 5 air changes per hour. But there is a petition for variance process that the state officials have said they would certainly consider in this case. Gas detection not required except for controlling a ventilation system, or it is required for LNG because it's non-odorized. And again, here's a quick summary of those requirements. Touch on this really briefly. In Wisconsin, the document that is out there has more information, detailed flowcharts on what a permit process looks like in the state. So that there are 2 of these. This is the one for buildings. There's another page for fire department approvals as well. So training, I don't want to, again, repeat too much here, but training is a big part of what of making a shop safe. And then also developing standard operating procedures, preparations for vehicle service, hot work. One thing to get LNG vehicles to a lower hazard is to run them to take the head pressure off the tank before you bring them into a shop, which will help increase your hold time. Tank inspections and gas detection calibration are all part of your systems that we need to deal with. So let's dig in a little bit to a couple of case studies. This one is Frito-Lay, and what they had done is converted a 3-bay garage for minor repairs of natural gas vehicles. They used the continuous ventilation compliance method, so there's no classified area at the ceiling. They sealed separation walls, and what's a little bit unique about this facility is they also do indoor fueling in adjacent bays, so that is separated by a firewall and completely separate mechanical systems. Next one, this is a waste hauler outside of Milwaukee. They had a 7-bay major repair garage. They ended up with a full upgrade for a major repair garage, including gas detection, purge venting, brand new heating system, and all the electrical in this building was actually rated for classified areas. It was prior to the state adopting those revisions to the electrical code. And then, again, we had adjacent areas that that needed to be sealed up, so we couldn't migrate hazardous vapors. Third one, pretty popular topic in the state of Wisconsin, and many of you may have seen this one before, but it's Quick Trip's shop. And what they had done for major repairs of CNG and LNG vehicles is to isolate one of their old wash bays. And you know, again, my hat's off to these guys because they did it very economically to get to this point. They ended up with all the typical features of a major repair garage, but they only did one bay here, so their cost was limited. They did plug the floor drain because LNG vehicles in this shop, and there were electrical requirements as well that they addressed at the floor and at the ceiling. And this one, to my knowledge, has not been built yet, but it's been designed. It's a City of Milwaukee repair shop, and their approach was to separate an area of a larger building that could accommodate up to 6 vehicle repair spots for major repair of NGVs. They separated it with partition walls and ended up, again, with all the bells and whistles, gas detection, purge venting. They used air handler system for heating, and one thing that's a little bit unique about this one is the lighting was actually uptight to the ceiling and also rated for the hazardous environment. So cost, this comes with a lot of disclaimers, but we have attempted to throw a dart, I guess, at the cost of these repair garages, and there's a lot more information in the Wisconsin document. They're based on a medium-sized truck garage, and they start with an initial assessment. You have to understand where you're going in order to get to some prices, and it's not intended to replace qualified estimates or engineering assessments. So here's some basic numbers. I've got a few slides of this, but we've got an engineer involved up top here. Then we go into the exhaust fans. That's per fan, $8,200 to $9,200 per fan, including electrical work to get that fan connected. Duct work by just positioning the fan such that we don't need the ducts and we can effectively ventilate all the spaces. Here's a number for detectors and controllers, and then we've got a special line item for a pit detector because of their increased cost of getting the wiring over there. We've also got a number for infrared tube heating. This includes all the electrical systems and controls that go with it, thermostats and zoning. Shunt trip breakers, so those are used to trigger or shut off electrical circuits upon detection. If you have space in your existing panels, you can just put those in there and trip whatever circuits you'd like to upon detection. Other items that we've listed here are separation walls and design management. Dealing with the design management portion of it is dealing with permitting, permit fees, and schematic designs. A few other costs here. There are many more in the document, but a few others are any demolition that might go with your project. Lighting upgrades, common if you're dealing with lights. A lot of times it's a good time to upgrade them. LNG floor drains, dealing with that, or roof access ladders. Access ladders are required when you put mechanical systems on the roof. We've already talked about some of these cost-saving strategies. Sealed partition walls as opposed to upgrading an entire garage. Hire experienced design professionals and contractors so you don't make conservative assumptions and which turn into expensive construction projects. And definitely consider your operational costs and your heating system. There are a few financial incentives out there, and more ideas are listed in the guidelines document. That's all I have, and we can turn it over.
Thanks, Steve. We'll take any questions at the end if anybody has them, and I'm going to pass it over to Brian.
I'm sorry, I missed that. Whose turn is it?
Brian.
Okay, it's Brian. Brian Curry with Ozinga. Good morning, everybody. Real quick, we have my background working with compressed natural gas trucks goes way back to 2008, where I managed a large fleet of trucks on the refuse side, just outside of Chicago. So early on, we didn't have a whole lot. I didn't have a whole lot of reference to go on, and there was certainly not a Clean Cities webinar that gave us all this good information. So I think the best way I'm going to put this is we took the most practical approach we thought was the right way to do things, and even to this day, I still follow the same practical approach to this thing, somewhat refined over the last few years. But what I did was we started out with basically looking at the ventilation and then tying the ventilation to a properly installed methane detection system. So I had, over the years, developed just kind of a list, and I've got this 6-page document which made it relatively easy, and I use this for handouts all the time now that we've moved into installing stations for other people. And we get asked a lot on what the requirements are, for their facilities or their shops. So I kind of put together a dummies guide for what to do or how to understand certain codes, regulations, requirements outside of what the local jurisdiction may be. I found dealing with local company or local fire marshals and local code enforcement people, most of them that we run into have no idea what a CNG vehicle is or what to do. And to be quite honest, we were almost afraid to even ask anybody, because with the concern being they might come in and look at an older facility that was built in the 1950s or was not up to normal International Mechanical Code ventilation requirements or IFC ventilation requirements, and end up, going down the road of implementing a compressed natural gas vehicle, then in turn spending $200,000 to $300,000 upgrading the shop. So we looked at just a basic understanding of what we would do and ran with it. So again, that's been refined over the years, and I put together a simple 6-page guideline on what the applicable codes are. That's what you're looking at right now. I'm not going to go through each code, but I'm going to kind of reference a couple things. But interesting with the codes, being in compliance with one code may not necessarily put you in compliance with another. We found that right away. Specifically to that, if you look at the ventilation requirement, and we see this a lot with our shops. We've got 11 shops, and I ran a shop or a couple with 7 other shops. Any shop being built, especially the older ones, a lot of shops were retrofits out of an existing building, which may have been a warehouse at one point, or never was really built to be a vehicle repair shop, or it may be a brand new shop. And typically what you'll see from a ventilation standpoint in a lot of these shops is where, and Steve and Ted touched upon this, typically in a vehicle repair shop per code, you're going to pull that air for the exhaust down close to the ground, I believe 42 inches off the ground. You're typically not taking that air and pulling it from the ceiling. So, the simple requirement of being in compliance with standard international mechanical codes and IFC codes, and if you look at, simply put, turning on, to be compliant, working on a CNG vehicle in a major repair shop would be continuous ventilation. Well, anybody working in a northern extreme like Chicago or Wisconsin is not going to want to turn the exhaust fans on and leave them running continuously. So sidestep that requirement. You look at it installing, obviously, and what we do is we purchased a methane detection system for each facility. The methane detection system that we install are typically all infrared. So what we would do is we would size the kit or the system for the shop. Let's say the shop's got nine working bays. Assess the way the bays were configured and how many trucks would fit into each bay. And looked at it from a common sense perspective, where if one truck would fit in that bay, we would center a methane detector over the working area of the truck at the highest point of the bay. So if there was 2 trucks, or if you had 2 tractors that can pull in back to back or nose to nose, we would add 2 detectors per bay. So that system typically would be what we do nowadays, infrared versus a catalytic system, where I think Steve touched upon this, requires a 2-year, or I'm sorry, it's a semi-annual inspection, or inspection once every 6 months. And when you buy these kits, you buy the equipment that you can test with the kits, or we'll buy one kit and actually do it from other people at this point. But going back to the ventilation, obviously looking at existing ventilation in our shops was very minimal, or was built to code to be compliant with heavier than air fuel. So I looked at, and I've experienced this with vehicles that are compressed natural gas coming into a shop that's considered a major repair shop, where you're going to be working on the fuel system, you're going to be changing fuel filters, and you're going to be using torches and welders, plasma cutters, carbon cutters, etc. Obviously, any shop I've ever worked in has always been major repair. So we were looking at not setting up specific bays to be compliant, because it wasn't practical. And there's, especially when you're taking a fleet and converting it, 1, 2, 3, 4, 6 trucks at a time to displace diesel with CNG. At some point, every vehicle in your shop will be a CNG. So the 1 or 2 bay configuration wouldn't really make sense. So we always approach this from the whole shop perspective. The ventilation that we found, being whether it was compliant or not, to us that we would want to have that ventilation system tied to a methane system or run continuously, because in the event of a gas release from a pressure relief device or a leak in the system, again, look at a practical common sense approach. Natural gas is lighter than air. I've seen tanks vent inside shops where, for instance, it would be fueled outside in a fast fill dispenser that wasn't temperature compensated. The driver would put in 3,600 psi. It was -5 outside. That truck would come into the facility either later on that morning or right thereafter. The gas would warm up, and then the pressure would increase over the pressure relief device range on the vehicle tank, and you'd get a sudden release of gas in that shop. It's a loud, scary noise. Each shop that I've installed a system that's worked where that gas will obviously rise right to the highest point of the ceiling and dispense in the ceiling, nowhere near the exhaust intake for a compliant vehicle repair shop that was designed for heavier than air fuel. So what we looked at was, obviously that made sense to me, where we would upgrade the exhaust system to be compliant with another code, which was the NFPA code regarding electrical classifications, and I've got that on the screen now. We took a look at, instead of upgrading the exhaust system to be compliant with standard international mechanical code, or the IFC, if you look at this chart, which is the NFPA 38, table 83.2, looking at the second section, repair garage major, where lighter than air gases are fueled, it very explicitly defines the unclassified area within 8 inches of the ceiling where ventilation of at least XXX, a floor area, as long as the suction takes place from within 18 inches of the highest point of the ceiling. So again, that made sense to us, to where we would look at the shop, size of the shop, figure out the cubic volume of the shop, and basically add enough exhaust ventilation in the shop where it would equal 5 air exchanges per hour. And that's excessive. If you run an exhaust system at 5 air exchanges per hour, you can definitely feel it. As a matter of fact, if you install that many fans with the rated CFMs and did not include a fresh air intake, you could not even open up man doors leading to the outside. It would just suck the doors right to the building. So consider it emergency shop ventilation. So as we size these facilities up for maintenance for a CNG vehicle, we included fans that would be dispersed amongst the ceiling evenly, with their intake directly even with the highest point of the ceiling. Install a methane monitoring system tied to these fans, to where if there was a 25% LFL, it would immediately turn the fans on. It would either open up a overhead door to allow fresh air to come back in, which is perfectly legal, or we would tie a fresh air intake with louvers somewhere on the lower half of the building, so where we're going to be basically exhausting that air in the building via emergency ventilation if there was a 25% buildup or LFL. So they work very well. That's what I do all of my shops now. And as I mentioned before, we would put as many methane sensors as were required, or not even required, as needed to cover the whole working area of that bay. As long as the shop had a open truss roof, which, I've worked with shops that were either open truss or barrel style roofs where there's rafters that were open, and looking at the common sense approach where the airflow, if I'm putting in exhaust fans evenly across the ceiling, turning that exhaust on and bringing in fresh air, and there's an immediate evacuation of the entire shop air content, and it's pretty quick. So that system would be interlocked with the heaters, and we've done it a couple different ways. I've either used the methane monitoring control system to shut off the gas supply to individual heaters, or I've used it to shut off the main gas valve going into the building where I kill all the gas, which in turn would kill all the heaters at the same time immediately. It would open up an overhead door if it needed, or interlock my exhaust with a methane monitoring system to where the intake for the exhaust would open up with the exhaust fans. Sound an alarm. We put an audible alarm on the outside of the building with a red strobe, so the fire department would obviously see that there was a problem with a sign on the outsides of the building that there was a methane condition. And we've not in every case, but depending on whether or not the shop had a fire alarm system, using the various outputs of the methane monitoring control system, we would tie that to a trouble signal on the alarm and have that programmed to where you would have you'd be notified if it was after hours that there was a methane condition, as we call it, in the shop, and you knew at that point that the heaters were all turned off. Depending on how the site was set up, the overhead door was open, there was a security issue potentially, and then it would basically dictate a visit to the shop to see what was going on. So that's how we do it, and that's how I would do any other shop going forward. Typically, the one question we always get asked by a lot of people is whether or not you have to take and make the entire area that's 8 inches or below from the ceiling compliant with the NFPA 30A, which basically would make your electrical classification, which is again looking at the same chart. We looked at that compliance as far as what it would take to relocate all the electrical versus what it would take to make that area unclassified by adding in exhaust fans, which you can see clearly in the chart is okay as long as you move that much air in a certain amount of time. So we've never touched the electrical at any ceiling. We've always opted to put emergency exhaust in, which really, from a practical approach, if you think about it, and I've been in shops multiple times where the tank contents have released, that's where the gas goes. That's the area you want to release. That's the area you want to ventilate. And as long as you're doing that, you've met the ventilation requirements and you've met the electrical classification requirements. And it's a lot cheaper, depending on how old the building is, to add ventilation than it is to gut the ceiling and remove all the electrical that's up there. So that was more or less our approach. Moving down the line, getting into some of the best practices, I've seen, I'm going to touch upon the heaters. This is another question we get asked a lot too. What do you do with the heaters? And as Steve had said, the way the code is written, basically you can't install a open flame heater or a heater with a heat exchanger that exceeds 750 degrees in any area subject to ignitable concentration of natural gas. Yeah, that's a tough one. It's easy to make these decisions for a privately owned building. Typically in the past, I have not moved the heaters. Most shop heaters that I've been around have either been not in any modern shops where I've seen a few with radiant heat from the floors, which is great, but typically they're like any shop you may come across on a daily basis, which is going to be just a forced air heater. There may be a makeup air unit coming into the building after the exhaust, or there may be a radiant heaters that are hanging over each bay. Again, right or wrong, I've taken the common sense approach and looked at where the heater is, understanding where the gas is going to go relative to where the methane detector is. So I've always found it's very important to locate the methane detector in the right spot because that's the area that's going to sense 25% LFL and much higher than where any heater would be located. And typically, assuming that if I'm going to sense the gas that's 25% LFL way higher up than where the heater's located, I'm going to trigger that exhaust ventilation that's going to ventilate that shop before the gas has any chance of getting to the point where it's going to be combustible or near a heater. Now, I've been in shops where the heaters have been located, say it's a precast concrete roof. I've seen this a lot. There are lower roofs, older buildings where they put the radiant heat in between the precast columns. That one I would question as being whether it was a safe spot. But again, I'm not trying to do volume dynamics or engineer the facility and where the heater should be. Again, I look at it from a common sense approach. Look at where you're putting the methane system. Look where the gas is going to rise, and determine whether or not, practically speaking, that heater's in an area where there could be a combustible buildup of gas. It's going to be more combustible than where the gas is going to find the methane detector. And if you see that it's close, it's the best call. Use your judgment. Move the heater. Obviously, the easiest solution would be to change every single heater with an explosion-proof heater. You're probably not going to put radiant heat in the floors in an older building that's been built for 50 years. But if I were to design a new shop where I knew there was going to be CNG vehicles going into the shop, I would obviously probably go with radiant heat. But I've seen both, and again, it depends where it's at. But that's typically what we do. We don't touch the heater. We don't touch the electrical in the ceiling. Well, we'll overdo on the methane monitoring, and we'll overdo the ventilation. And I can tell you from a practical experience in real life, it's worked, and it's worked very well. And so that's our approach to it, at least. In addition to that, I think Ted touched on this a little bit. There's a IFC regulations for preparation for vehicle repair, which basically addresses how you should handle bringing a vehicle into the shop that's compressed natural gas. What we've done, kind of abiding by what those requirements are, I can tell you just a list of best practices that we found that you should do and follow. And what I do and what I've always done is for the mechanics working in the shop, we would do annual training that would cover maintenance on a CNG vehicle. And typically, in my 6 bullet points here, vehicles parked after being brought into the shop shall have that quarter turn valve turned to the off position. That's obviously the valve that supplies gas to the engine. These are attended vehicles in the shop requiring maintenance. Number 2, vehicles parked in the shop or garage or maintenance area unattended or overnight should have the CNG storage cylinders turned to the off position and the quarter turn valve closed. And then you're going to stive the engine to use up any fuel that's between either the quarter turn valve or the main tank valves. Now, I'll say this straight out. I've been around a lot of trucks, a lot of big shops. I personally think that you should not park a CNG vehicle in the shop overnight. You don't know what's going to happen. You don't know what's going to happen around that truck. I came out of the garbage business, so typically the rule of thumb was if there was a loaded truck that was broke down, you couldn't leave the loaded truck in the shop overnight because you never knew if there was going to be a garbage fire in the body. I took the same approach towards the CNG trucks to where, obviously there's going to be maintenance, it's going to break down, and we would basically drag that truck out of the shop every night if there wasn't if the shop wasn't staffed, which was basically on Saturday nights and Sunday. But nevertheless, if you were to ask me what I thought the best practice would be, that's what it would be. I would not leave one in the shop overnight. We also, as a best practice number 3, when welding or torching on or near a CNG vehicle, you're going to want to turn the main supply valves off. Typically, there's a cover over the tanks. There's usually an access hole for the tanks, whether they be mounted behind the cab, or if they're mounted on the frame saddle, or if they're mounted on top of the truck like a garbage truck. Typically, we would protect those holes with a fire blanket. And if anybody was going to be doing any welding or torching on that truck, we would assign a fire watch that would keep an eye on the area to make sure that there's no smoldering flames or chances of damaging the tanks. As everyone probably knows, if they've worked around the carbon fiber tanks, whether it be Type 3 or Type 4 tanks, any damage whatsoever as a result of fire is an automatic disqualifier for that tank, and you got to replace it. They're not cheap. So number 4, when maintaining any portion of the fuel system, including fuel filter maintenance, both the main supply valves and quarter turn valves should be closed, and the engine should be starved before you maintain any aspect of that system. So again, common sense, if you're going to change a high-pressure coalescing filter inside the fuel box, you're obviously going to want to do it with a 3,600 PSI potentially on the other side of that valve, so you're going to starve the engine. Number 5, a big one, especially for new deliveries, it seems like when trucks come from the factory, this is when they leak, or you'll find leaks on. And I'd probably say, most of these trucks either have O-ring face seal fittings or double ferrule fittings. Typically, once they're tight, they're tight. You're not going to see a lot of leaks. Depending on the cold weather, you might have O-rings that aren't rated for the extreme cold, and you'll see leaks there. But by no means should that truck leak. If you smell gas or you hear gas, you brought into the shop for troubleshooting. Typically, you make the mechanics find the leak on the outside of the building and identify where the leak is, then bring the truck in, isolate the cylinder, starve the engine, and fix the leak. And lastly, number 6, again, a no-brainer. I have horror stories I can share with you at another time on this one. Under no circumstances should a repair be attempted on a leak under pressure. In other words, if you've got a line under pressure from the cylinder all the way up to the engine, and you've got a small leak, I can't tell you how many times I've seen mechanics just take a channel locks or a crush wrench out of their back pocket and go to tighten that fitting. It's probably one of the stupidest things you can do. I've seen lines fail because they weren't crimped properly. So again, identify the leak first, isolate it, and then repair the leak with no fuel in the system whatsoever. So that's my story. That's what we do. Right or wrong, I think it's the most practical approach, and I can tell you firsthand, it works and it's safe. And we choose to do things consistently. As far as the investment is concerned, I did not see the slide for the methane systems. We actually rep Sierra Monitoring, and we'll sell their equipment, but typically like a 9-bay shop, 10-bay shop, you're looking probably around, for all of the, if you did an infrared system with the control module, the strobe light, all the cabling that runs to the sensors, you're probably looking in the range of $25,000 for a complete system. And then, of course, ventilation, depending how big the shop is, how many cubic feet it is. We'll obviously determine how many fans you're going to be putting in, where the fans are going to go. I typically, having a guy come in and put a couple of exhaust fans in, depending on how big the shop is, I'd say you're looking at anywhere around $25,000 with electric. So, for a normal shop, you're probably looking, normal shop being 9-10 days. I'd say your investment on what we do, again, depending on the number of bays, shops, existing exhaust system, you're looking probably between $50,000 to $75,000 to make it compliant with what I just went through. And of course, that's not touching the electric in the ceiling, and really not making any change other than adding ventilation and adding a methane monitoring system. And that about sums it up for me.
Thanks, Brian. There's no questions at this time, sure. But if anybody has any questions, they can email myself, Stephanie, or Erica. And thank you again to our presenters. And our next webinar is going to be on February 20th, Station Installation Guidelines for CNG on February 20th. And again, thank you, and I hope everybody has a great day.
Thank you.